Hi, welcome to our discussion today on interpreting distance versus time graphs. Today we'll learn how to read linear graphs as well as curved graphs. Let's get started. So we've got a graph here of motion, and we have a red line and a blue line, and we can see that the red line is steeper than the blue line, and we want to try to figure out what that means. So to do that, we can take a look at what happens every second to the distance these things travel. So you can see, here's our time and our distance. So at 1 second, the red line has traveled a distance of, right here, 7 meters. Went from 0 meters to 7 meters. And in the second, so I'll draw over to the second over here. So that's our second gone by. They travel another 7 meters. From 7 meters to 14 is 7 meters. So here they've gone 7 meters. Here they've gone 7 meters. That took 1 second, and this took 1 second. So we can see that this line is moving at a rate of 7 meters per second. Okay? Now the blue line has less of a slope. Let's see what that means. I'll switch over to a green pen. So in this first second, instead of going a full 7 meters, this blue line actually only goes 2 meters. And in the second, it goes 2 more meters. And then the third second, it goes 2 more meters. Fourth second, 2 meters. Fifth second, 2 meters. And sixth second, 2 meters. So there's a few things that we can tell from this. Each of these are 2 meters. That tells us that, hey, we must be moving at a rate of 2 meters per second, because each one of these is a 1 second interval. So two things we learned from this. One is that steeper is equal to faster. So the steeper the line on this time graph, the faster the object's moving. And also, we learned that straight lines equal constant velocity, because you go the same distance every second when it's a straight line. Awesome. So those are our two big things we've learned so far. Now let's take a look at this next graph, which is a single object, but this object is going to change speed. We just learned that steepness is speed, or velocity. So it starts out with a large velocity here, and then suddenly it changes and has a slower velocity. And then we have this new thing of straight across this horizontal line, and we'll learn that that's zero velocity, not moving. And then there's this downward sloping line, and we'll have to figure out what that means. But let's start with this first part. So if we want to know the velocity in this first part, we draw another triangle like we did above. So we draw over and we draw up. And that will give us how far we traveled and the time it took. So you can see from this one that we started at 0 meters, ended at 10, for a total distance of 10 meters traveled. And that took us 2 seconds of travel. So if we do 10 meters divided by 2 seconds, we see that our rate is 5 meters per second. The only way to make 10 meters in 2 seconds is to go 5 meters each second. Okay? Now for this next part, we're not going to start at the bottom. We start at where the line starts, and we go over and then up. And here you can see that we started at 2 seconds and ended at 4 seconds for a change in time of 2 seconds. So 2 seconds have gone by. And here we started at 10 meters and we go up to 14 meters for a change in distance of only 4 meters. And if we do 4 meters in 2 seconds, that means we must be going 2 meters per second. So 4 meters divided by 2, just like 10 meters divided by 2 seconds here. Now on this one, you'll notice that we aren't going anywhere. We're staying at the 14 meter mark. We're not getting farther away or closer to, so that's 0 meters per second because we're not moving. Now on this one, things get a little bit tricky. So this one, we're headed down. We're not down, I'm sorry, we're headed losing distance here. So we're going from 14 back to the starting line. So that means we're losing distance, we're going backwards here. And then it takes us that much time. So that's our slope triangle. I'm going to draw this in as negative 14 meters. Now this is negative because I'm now losing distance. I'm going backwards. It's a negative change. And this is 1 second. And of course that means that this velocity here is negative 14 meters per second. Right? So now we've learned a few more things. Let's write them down. We've learned that horizontal is equal to 0 velocity. And we've learned that negative slopes are equal to backwards motion. Awesome. So now we know steeper is faster, straight lines are constant velocity, horizontal lines are 0 velocity, and negative slopes means you're moving backwards. Let's look at another one. So this graph is a little more complicated. We're back to having two different runners, a red runner and a blue runner, but now their graphs cross each other in the midpoint here. We got to figure out what's going on. To start with, let's look at the red line. So we can calculate the velocity of the red line by drawing our slope triangle again, where we start here, go over, and go up. And this right here is 6 seconds. And our distance we traveled isn't 10. It's a common mistake. People say, oh, I went 10 meters. But really, you cheated because you started at 4 and you ended at 10 for a total of only 6 meters. That means your speed must be 1 meter per second. That's your velocity, I should say. Now for the blue one, I'll switch over to pink. And we'll say, okay, in those same 6 seconds, our blue runner went the full 14 meters. So here's 6 seconds, and here is 14 meters. Sorry, I'm squeezing it in the corner there. 14 meters. And if you do that math, you end up with about 2.3 meters per second, and that's 14 meters divided by 6 seconds. Now, something else to notice here is that the velocity for the red and the blue, they're both constant velocities because they're straight lines. This one never got steeper or less steep, so it's 1 meter per second the entire time. This point in the middle does not represent a speeding up or slowing down by either person. It's simply where the faster blue person is passing the red person. Okay? And this y-intercept being non-zero, that indicates a head start. And this point here is where blue passes red. Okay, let's look at one more on this page. All right, now this last one can be super tricky. So the first thing to notice is that red, once again, got a head start, except this time it was a 6 meter head start instead of a 4 meter head start. And the question is, who's in the lead? Well, at this point, red is in the lead and stays in the lead. So you may think initially, hey, well, red must be running faster. But remember, it's the slope that tells us how fast you're going, how much distance you're going each second. Notice that red starts out 6 meters ahead, and red ends 6 meters ahead. The slopes of these two lines are actually identical. One of the first things you should notice about these curved graphs is that the amount of distance you're traveling each second isn't constant. So let's take a look at that real quick. We'll actually use 2-second intervals to make life a little easier. So in 2 seconds, we traveled that far. In the next 2 seconds, we travel that far. In the next 2 seconds, we travel that far. Notice how these 2-second intervals, the distance traveled, it's getting bigger and bigger and bigger. So we start out with this distance, bigger distance, bigger distance, bigger distance, bigger distance. The velocity is changing, not staying constant, and that's what curves do for you. So let's write that down. So now we know that curves equals changing velocity. And we have a word for changing velocity, and that is, of course, acceleration. Okay. So terrific. Let's clear that drawing out and see if we can't do some more work. Now, as we're trying to figure out what's happening with these curves, we're going to draw, at the beginning of the graph, we're going to draw a line that matches the slope of the curve at that point. So here's my little line segment. I'll do the same thing in the middle of the graph, and again at the end of the graph. And these little line segments will help me analyze what's going on. So we remember from before we said that, hey, steep means fast, not steep means slow. So here we've got a line that's not steep, so this must be slow. This one kind of has a medium steepness, so it must be a medium speed. And this one is super steep, so it must be fast. So on this graph, we're going from slow to medium to fast, which means we must be speeding up. And we're increasing distance, so we must be moving forward. We're gaining distance. And that's the analysis process. So the first thing to do is draw these little tangent lines, these little slope lines here at different places along the graph, and then see if it's getting steeper or less steep. Okay, let's get another one. All right, so in this one, we'll do the same thing. We'll draw a little slope line here at the beginning, one in the middle-ish, and then again one at the end. Right? This one starts out super steep, so we must be moving fast. This one's kind of a medium, so it must be a medium speed. And this slope is almost zero, so this one is really slow, if not stopped. So we're going from fast to medium to slow, and we call that slowing down, of course. Now again here, we're still gaining distance. We're getting farther away, so we're still moving forward. So in this graph, we'll draw our 3 tangent lines again. Our first one is sloping about like that. Our middle one looks about like that. And our ending one is about like that. And of course, from that, you can see that this is not steep, so slow. A medium steepness, medium speed, and really steep here, really steep, fast. Remember, it doesn't matter whether it's sloping up or sloping down. It's the amount of slope that tells you how fast it's moving. This is changing a big distance every second compared to a small distance. So here we go from slow to fast, so we must be speeding up. Now notice we start out really far away and we get closer to the finish line. That must mean that we're moving backwards. We're losing distance. So this is speeding up backwards. Now our slope lines, we're going to draw 3 slope lines again. One in the beginning, one in the middle, and one in the end. You can tell our first slope line is really steep, so that must be fast. This is a medium-ish slope, so there's a medium speed here, and this is a very small slope to almost zero, so this one is slow. So when you go from fast to medium slow, we call that slowing down. And because we're losing distance, we must be moving backwards. So pause the video. When you're ready to see the results, hit play again.